What's going on everyone, you're back with your boy Jono for another quick math lesson. Today we're going to work out, is a point on a line? The reason that we are looking at this is because we want to know, without having to graph out these massive graphs, if a point in the future would fit on our linear relationship. The fundamentals of this idea is incredibly easy, and I think you're going to find it pretty cruisy. So please stick around to the end of this lesson, and I reckon you'll be on top of this subject. So if we have an equation that looks like this, y is equal to 2x plus 1, we just have to find out, hey, is that point on a line? No? Great, you've basically done this topic. It is a little bit harder than that when we are given algebraic terms, but this is the major concept. We can see that that straight repeating pattern is going straight up, and this extra point is not part of that pattern. If you can do that, that's basically the major skill. We're going to see how to do this just algebraically, but this is the major key point. Unfortunately, we won't get given a graph for most of these questions, and we don't want to have to draw one instead. We want to be lazy. So we'll be given an equation, and we'll be asked to find out whether or not a point is on that line of the equation without having to graph it. So the way that we're going to prove that this point is not on the line is by actually looking at the points that are on the line. So if I've got y is equal to 2x plus 1, the first point that I've got here is at 0, 1. That's the y-intercept. X is equal to 0 because it's on the y-axis, and we're 1 up. So I'm just going to sub this into the equation that was given. Y is equal to 2x plus 1. That means that I've got 1 is equal to 2 times 0 plus 1. 1 is equal to 1. That actually makes a lot of sense. This means that this point is on the line because this statement is true. Let's have a look at the next point up. It's at the coordinates 1, 3, and we're going to sub those 2 points, the x and the y, into the equation that we've been given. So this means 3 is equal to 2 times 1 plus 1. 3 is equal to 3. Happy days, this is also true. So for this last point, we've got 2, 5. So if I sub those both in, I've got 5 is equal to 2 times 2 plus 1, which is again equal to 5. So you might be seeing a pattern here. When we put in numbers that are on the line, the end result is always true. 5 equals 5, 3 equals 3, it makes a lot of sense. But if you sub two numbers in and you get a false statement, that's when we know for sure it's not on the line. So for our point here that we know is not on the line, its coordinates are 3, 4. If I sub those two numbers in, I've got 4 is equal to 2 times 3 plus 1. 4 is not equal to 7, that's a false statement. So that means we know for sure it's not part of this linear equation. It doesn't exist in space. So we know that this point is not on a line, not just because we looked at it, but we also proved it algebraically. So basically all this boils down to is a massive game of true or false. You sub in the numbers that you have, and if it's true, it's on the line, and if it's false, it's not. So if you can substitute numbers in and then see if 3 is equal to 3, or if 3 is equal to 4, you can do this whole topic. Just, hey, is that true or false? We're going to look at a couple of examples. So we want to know, is the point 3, 1 in this linear equation? So y is equal to 4x minus 1, and I'm going to sub my numbers in. X here is equal to 3, y is equal to 1. So 1 is equal to 4 times 3, which is 12, minus 1. 1 is equal to 11. That doesn't make any sense, that's false. So this point is definitely not on the line. And that's all it is. That skill is it for this whole topic. Looking at a very similar example is the point 1, 3 on this line. Now if I sub these two in, I've got y is equal to 3 and x is equal to 1. So 3 is equal to 4 times 1 minus 1. 3 is equal to 3, so that must be true. This point here is on the line. We could probably work that out by being, oh yeah, the y-intercept's at minus 1, it goes up 4 spots, but we don't need to worry about that. As long as you can sub these two numbers in, work out if it's true, we know if it's on the line. The only real thing that you've got to look out for is if there are negatives. So please just make sure you check for these. Anytime we've got a negative gradient and a negative point, we just have to make sure we do end up with a positive answer. So I want to find out if the point negative 2, 17 is on this line. So y is equal to negative 4x plus 9. I've got to sub these two things in. So I've got 17 is equal to negative 4 times negative 2 plus 9. Negative 4 times negative 2 is equal to 8, positive 8. So now I've got 17 is equal to 8 plus 9. 8 plus 9 is 17, so this thing is true. That point there, even though it seems like it's really far away, is on the line. So that's all we need to know for this topic. If you can sub in numbers and find out whether or not they're true or false, you're in the money. We're going to give you the points every single time, so all you've got to do is chuck them in, Again, I would always use brackets if you can, but if you throw them in, make sure you're looking for negatives. I think you're going to be fine. Thanks so much for watching this lesson, and I'll see you later.